So here I found a list of some Pythagorean triples. So you can pause the video and you can try to see if these actually work. So we know this one works. So 3 squared plus 4 squared, that's 9 plus 16 equals 25. So that works. So try some of these other ones. What about this one? 8, 15, 17. I think we did that one too. Try this one. 17 squared. So let's try 17 squared plus 144 squared. So I added up those two squares. It equals 21,025. 21,025. So let's try 145 squared. What would that give us? Will it give us 21,025? So 145 squared. Yes. So this is a Pythagorean triple. So there are many. Here are just some that I found. So maybe check these other ones, see if they work. Okay, let's try this example. Okay, here we have an example. It's an isosceles triangle. So the tick marks are telling us that these two sides are the same. So if those two sides are the same, then they would have the same value. So I could use A, and I'm also going to use another A. I'm not going to use B because they're the same. If I would use B, it would imply that these are two different measurements, but they're the same measurement. So let's go back to the formula. The formula says A squared plus B squared equals C squared. But in this case, B and A are the same. So it's really A squared plus A squared equals C squared. And if we remember, these are like terms. A squared plus A squared, these are like terms. So it's like saying 1A squared plus 1A squared is 2A squared. 2A squared equals C squared. So let's put in the value for C. We know what C is. So 2A squared equals 11 squared. So now we have 2A squared equals 121. So what do I do to both sides? Remember, I'm trying to find A. I'm trying to get A all by itself. So let's get rid of this 2 by dividing both sides by 2. So I'll divide this side by 2, divide this side by 2, and I'll get 2 divided by 2 is just 1. So I'm left with A squared equals 121 divided by 2. That's 60.5. And now A squared equals 60.5. I have to take the square root. So the square root of A squared is just A. And the square root of 60.5 will be my final answer. And now the side length should be less than 11 because 11 is the longest side. So let's see, what do we get when we take the square root of 60.5? Here's my calculator. So 60.5 square root, 7.8. Let's round it off to 7.8. So it's about 7.8. And that is our missing side. 7.8. What if we know these two sides and that one is missing? So let's try that example. So in this example, we still have an isosceles triangle. We know this is 4 and this is 4, but we don't know the hypotenuse. So we don't know the hypotenuse. That's the missing side. Let's call that C. So this is A and B are the same, but we don't know the hypotenuse. Let's write the formula again. A squared plus B squared equals C squared. So in this case, A squared and B squared, A and B are the same. So I'll write 4 squared plus 4 squared equals C squared. This is 4 squared, 16 plus 16 equals C squared. So C squared equals the square root. 16 plus 16 is 32. So C equals, not C squared, but C equals square root of 32. And your final answer would be the square root of 32. I'll use the calculator. What is the square root of 32? Well, 5 times 5 is 25. 6 times 6 is 36. Let's see. It's in between. So 5.65. 5.7. Let's round it up to 5.7. So Here it's 5.7. And again, we see that 5.7 is bigger than 4. It has to be the biggest side. So 5.7.